Alright guys, in our quadrilateral section we are now moving on to rectangles. So we talked about our parallelograms, and our next quadrilateral we're going to talk about is our rectangles. The first thing we need to learn about rectangles is they are going to have all 5 properties of the parallelogram. So a rectangle is also considered a parallelogram because to be a parallelogram you have to have those 5 properties we talked about in the previous notes. A rectangle does have those, so technically a rectangle is also a parallelogram. Okay? In addition to that, we have 2 more properties that make it more specific to a rectangle, and that's going to be, first, we have 4 right angles, and over here in our first rectangle, we can go ahead and put that in here. We have our 4 right angles, which is something we should already know about rectangles. And the next one is going to be your diagonals are now congruent. Remember that in parallelograms they bisect each other, but now they are also congruent. So they're going to be congruent and bisect. So we take a look at this. We're going to have congruent, and we could just put like a little tick mark here, a little tick mark here. But what's going to end up happening is because they are also being bisected, all 4, from the center to all 4 corners, every single one of these is going to be congruent. That's what's changed with the diagonals. Let's take a look at our first example here. Again, we don't have all the labelings to prove these are rectangles, but I am going to tell you right now it is a rectangle. Okay, all of these will be. So on number 1, we're taking a look at what property, including the 5 properties of parallelograms, are we going to use to solve for x. And this is going to be that our opposite sides are. So when we look at our properties of the polygons, we see our opposite sides are going to be congruent. So here to solve for x, we'll note up here that the property we're using is that opposite sides are congruent. So again, when 2 sides are going to be congruent, their measurements will be equal. So we'll just set these equal to each other. So we'll have 2x minus 4 is equal to 36. And like what I've been doing to make the video shorter, I am about to pause my recording. You need to pause yours and solve. That way you can go through and solve it on your own, and then the answer is about to pop up, so please. All right, when we solve for x, we should have gotten 20. So 20 is going to be our answer here. We move on to example number 2. We are told that AC, so from A to C, is 6x plus 3. So I'm going to go ahead and kind of do this thing here. Put 6x plus 3. And it tells us that DB right here is going to be 33. So right here will be 33. So we're looking at the diagonals, and so let's think about what our diagonal properties are. We know from the parallelogram section of it, they are bisected. But now one of our new properties here is our diagonals are also congruent. So again, diagonals are congruent. Their measurements are equal. So here we'll go ahead and write in the diags are congruent. And we'll set this up equal to each other, just like every time things are congruent. 6x plus 3 is equal to 33. Again, let's go ahead and pause so that you can solve it on your own, and then the answer will. In the end, we should have gotten x is equal to 5. If you did not get it, double check your work. Number 3, we're now going to move to some angles here. We're told that the measurement of angle right here, A, E, B, right here, is going to be 12x. Ease in the way a little bit. And we're told that the measurement of angle DEC, so D to E to C, is 10x plus 20. So this problem is actually, when we're going to solve for x, it actually doesn't have to do with any of our properties here. We have to take a trip back in the time machine to first semester and look at what we have here. In the end, we do need to also pay attention that they want the measurement of angle AEB. So after we solve, we need to substitute back in for that 12x. Here we need to see that we do have a pair of vertical angles. And as we've learned, vertical angles are congruent. So we will set these equal to each other. 12x is equal to 10x plus 20. Again, pause the video now, please. The answer is about to pop up. So I just go ahead and solve for the x for right now, and then we'll go ahead and play through with the substituting in. We should have gotten 10 for x. So now we're going to substitute in for the measurement of angle AEB. This was a 12x, so we're going to take out that x. We're going to substitute in for x. We're going to put in 10, and 12 times 10 is going to give us 120. So the measurement of this angle is 120 degrees. We can go ahead and write up here so we know, even though it's not a property, how did we know to set it equal to each other? We had vertical angles. All right, the next problem here, number 4, we're looking at AE, so from A to E right here is 24, and from E to C right here is 5y minus 1. So we're going to solve for y. So we're talking about these angles, or sorry, the diagonals again, and we know that from parallelograms, which a rectangle has all those properties, our diagonals bisect each other. So here we're going to have congruent segments. So again, we'll set this equal to each other. We'll go ahead and note here the diags are bisected. And we're just solving for y, so 5y minus 1 is equal to 24. And this is where you pause it. I'll give you a couple seconds before I pause my recording, and then the answer will come up. In the end, our answer to y should be 5. Double check that work if you did not get 5. Last problem, quadrilateral ABCD is a rectangle. We're looking at the measurement of angle DAB. So let's go find the measurement of angle D to A to B. So we're talking about this angle right here. Okay? This is going to be 7x plus 6. And that's all they gave us. But we do have another property of rectangles that we have not addressed in any of these practice problems, and that's going to be our 4 right angles. So knowing that we have our 4 right angles, we can draw in our 90-degree right angle boxes. First one didn't look too good. And so if the angle is 90 and it's also 7x plus 6, we just set them equal to each other. So here the property is our 4 right angles. Again, we have that 7x plus 6 is equal to 90. Let the recording go for a couple seconds before I pause mine so that you have a chance to pause. All right, ladies and gentlemen, x is going to come out to 12. This is what we should have gotten. Okay. Now let's go ahead and go over to our flow chart, and let's fill out our rectangle flow chart as well. Again, we're starting with our quadrilaterals. So everything on here, they're all quadrilaterals, all 4-sided. And then we moved the flow chart down to our parallelograms. We're more specific now. We have these 5 new properties that we talked about. So the quadrilateral got more specific, more detail to it. We're going to take that parallelogram. It's still going to be a parallelogram, but we're going to go over here to the rectangle and add more properties. So again, how you're seeing this is a rectangle down here is also a parallelogram and is also a quadrilateral. You move back upward, and everything down here is going to follow backwards through those arrows, and it's going to be all of those. So the rectangle was also a parallelogram, is also a quadrilateral. So your properties here, we actually have a couple, we have 2 new properties. The first bullet point here is that we have all the properties of a parallelogram. Then we talked about the right angles. Well, how many right angles did it have? And you had 4. And then we established that our diagonals are congruent. And that is it for the rectangle note.